Okay, we're preparing for your test on data displays, so scatter plots, box and whisker plots, bar graphs, over graphs, all the above. First, the easy ones, mean, median, mode, range, all that. Median is the number down the middle. That's all you need to know. Middle, median, like the median of a highway. Mode, M-O, most often. Again, straightforward. The mean is the average. So that's where you add them all up. So add them up and divide by how many there are. So divide by the number, not the hashtag, that there are. And then the range is just the high number minus the low number. Just like that. Okay, first thing you need to do before you can even find a median, or really anything, you need to put the numbers in order from least to greatest. So you need to be in increasing order from least to greatest. How do you determine correlation of a scatter plot? All you're going to do is look at the line of best fit. If it's going up, so it's positive slope, that would be a positive correlation. If it goes down, that's a negative correlation. If it's all over the place, something like that, that would be a no correlation. You can use pictures to help you. If you want to draw examples of it, that is absolutely fine. Now, the difference between range and interquartile range. Range, we said again, was the high minus the low, like we said here in number 4. Interquartile range means the inside range. So I might even write that. It's the inside range, which means you're going to take not the highest and the lowest, but the next quarter. So it would be like the third quartile minus the first quartile. The inside subtraction, the inside range. Okay, those questions should be straightforward and put on your test. Number 8, there's going to give you data here. Again, first thing you need to do is try to put them in least to greatest order. So 8, 9, 10, 12, 12, 14, 15, 18, 20, and 21. Mark them off as you go. 8, 9, 10, 12, 12, 14, 15, 18, 20, 21. There should be 10 for each. I would double check and make sure that your numbers are the same. So, finding the mean, that's really easy. Just add all these numbers up and divide by 10, and you should get 13.9. The median, down the middle, there's 10, so 1, 2, 3, 4, 5, count from the edges, and here's your median. Well, it's right between 12 and 14, as you count from the edges here. Boom, boom, the whole way down. You got 2 guys left in the middle. You can't have 2 medians, you can only have 1. So what we do is, we can say one of 2 things. What number is literally right in between 12 and 14? That's just 13. Or you can figure it out by saying, well, I can add those 2 up, 12 and 14, and divide by 2. Find the average of those 2 numbers. Either way, you're going to get 13. Mode, what occurs most often, that's the 12. Range, high minus low, so 21 minus 18, or 21 minus 8, I'm sorry, is 13. Max and min, that's pretty straightforward. Biggest is 21, lowest is 8. Now the interquartile range, that's finding the difference between Q1 and Q3, meaning we need to find the middle of the lower half and the middle of the upper half. So the middle of the lower half is this 10, the upper half is the 18, so you do 18 minus 10 to get 8. Okay, on to some graphs. Here's a dot plot talking about how many points somebody's scoring in a game. In the 23rd game of the year, so this is after 22 games. After the 23rd game, they're saying that he scored 20 points. So another X is going to go right there. They want to know how the mean, median, and mode and range are all going to change in the course of adding that number in it. Well, let's look at these 3 because they're very easy to see. The median, the mode, and the range. The median is the one down the middle. Okay, so we'd have to go and mark down the middle. So originally, if you count them off, there's 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your median would be right there. Your median was 24. Now that we've added this, now we want it to be the 12th guy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is your median. Did your median change? Its location changed, but its number is still the same. So the median, there was no change. Mode, what occurred most often? It's still 24. So again, same thing, there's no change. I might even try to jot down why that's the case for each of these. So median, it's still 24. The mode, okay, 24 is still most often. As for the range is just high minus low. Well, I didn't change the highest or the lowest. So again, no change here because the high and the low are still the same. Now, mean is the one that is almost guaranteed to change every single time. What you would probably want to do is just this. You should actually go and find the mean to begin with. So before this 20 was here. When you do that, you would get a mean of like 23.3 originally. Unless your new number added is the exact same as this guy, your mean is going to change. Because I added a number that's below my average, with the new number, my average, my mean, will decrease. That's all you got to say. If I had added a number like 29, obviously it's bigger than the mean, bigger than the average, then my average would have increased. So that's all you need to say. Find the original mean and see where the new number lies compared to that mean. If my mean was 27 exactly and I added a 27, then the mean would not change. All right, box and whisker plots. Highest score and lowest score in a test, you're just going to look right here where these endpoints are. I'm going to say the highest score, I'm going to call that, I don't know, 98, 99. I'll call it 98. And lowest score, 78. Or not 78, I'm sorry, that would be 68. Again, if they're not precise, like if you said 99 and 69, for example, I would not mark you wrong for those. The range, just subtract those two numbers you just found, that's 30. Interquartile range, so that's subtracting from the boxes. So I'm going to call that 93 and probably 78, so my interquartile range is 15. Okay, what percentage of students scored above a 78? Okay, so here's where 78 is. Remember, each box represents 25%. Each part of the box. So above 78, there's three portions of it, 1, 2, 3. So that means I have a 75% of the students scored above that 78. Then the last one, how many students, not the percentage, will advance to algebra? Well, it said up here at the beginning you needed to score an 85 to advance to algebra. So make sure you're reading those words at the top. Here's where 85 is. How many scored above that? Well, it's 50% scored higher than that, but it doesn't want the percentage. So what I need to do is figure out, well, 50% of what? 50% of the number who took it, which is 64. So 50% as a decimal is 0.5. I just do the percentage times the total. So a half of 64, which is 32. So 32 students moved on to take algebra in the 7th grade. Okay, on the next one, it's just drawing a line of best fit. Now I'm going to cheat because I have a straight line maker, but you're going to be able to do the same with a ruler. What we want to do is just kind of estimate some sort of line so you have the same number about below and above the line that you draw. So something like that could possibly be a good example. Looks like you have about the same amount below and above. Main thing I want to point out, you don't need to start at 0. You don't need to go through any points. Like I didn't go through a single point on that entire thing. A lot of times people try to, line up the first and the last point, something like that. That's not always correct. Okay? Could work that way. It could go through 1 point, could go through 5 points. It doesn't have to go through any of them though. So just try to estimate it best you can so that you're going through, or not through points, but you're putting the same number above and below as you can. Kind of follows a pattern. Okay, next one is actually writing an equation for a line of best fit. So the first thing I might have to do here is I'm going to kind of extend this line if it doesn't go all the way. That's what I'm going to do first. And with this, we're always going to do y equals mx plus b. The b is where I begin. So what is that point right there? It looks like it's at about 4.5. So I'm going to call that 4.5. And now for my m, for my slope here, I'm going to notice is just the line I drew actually kind of went through these 2 points, which is kind of nice. So I'm just going to kind of mark where they are. So this is the point 8, 7. And this point right here appears to be the point 10, 8. So to find slope, what I need to do is subtract the y values up top. So that would be 8 minus 7. Subtract the x's on the bottom, which is 10 minus 8. So I get 1 over 2 as my slope. So my slope is 1/2. So that's my equation. Y equals 1/2 x plus 4.5, 4.5. Yours might be a little bit different depending on what point you picked, or depending on how you drew your line, or in this case the line was already drawn. So mainly it's about trying to find 2 points that look very good and usually they'll have a couple points there for you to kind of work off of. Okay, how many eggs should be expected to be found in the 16th minute? So this is dealing with minutes and how many eggs are found in your Easter egg hunt. Well, it doesn't go to 16. Well, here's where 15 would be, and here's about where 16 would be. So if I go up here and see where about it is, well, it looks like it's kind of between 10 and 11. So can you really find a half of an egg? Probably not. So if you said, if you said 10 and a half eggs, I'd be okay with that. On a multiple choice, I'd probably say 11 eggs because you'd round up, sort of thing. So that's kind of what I'd be looking at there in terms of how many eggs we are predicting. Okay, and number 18, which of those lines, we have this is line A, B, C, and D, which one represents the correct line of best fit? Well, these ones definitely are too flat. They're not representing what's going on at the top and bottom, so A and B definitely should be out. As for between C and D, D, again, kind of has these outliers on the side we don't want to deal with. C is the one that best follows the pattern the entire way through. C is the answer that you're going to want for that line of best fit. Okay, coming down the home stretch here. 19 and 20 with the bar graphs. What percentage said that blue was their favorite color? Well, percentage, all you're always going to do is the number that you have over the total. So in this case, the number of blue was 15. The total, you could add them up, or it says it right here at the top as well, was 55. So all you do is 15 divided by 55. And when you do that, it comes out as 0.2727 over and over again. So I change that to a percentage by moving the decimal 2 places. And I'll just call it, I don't know, 27.3%. You could have said 27, 27.27, either way. If 20 more students are surveyed, how many would be expected to select green? So if I want a number, what I'm going to do is I'm going to take the percentage and multiply it by the total I'm talking about. So first, I need to find the percentage that we had already for green. Well, there are 10 who chose green out of 55, so that's going to tell me a percentage as a decimal. What I need to do is take that fraction and multiply it by my new total, which is 20. And when I do that, I should get an answer of about like 3.7, I think it comes out to be. Well, I can't have 0.7 students, so I'm going to say we're going to expect about 4 students, for the new students, to select green. If they said how many total students now, then you would say, well, there was 10 already, 4 more, so it would be 14 students in all. Okay, circle graphs. First one, if they give you percentage, and they're going to say then what a total you might have to work with is. So your total monthly budget is $2,500. They want to know on utilities and food. Well, here's utilities, here's food, so they combine to give you 30%. 30% of the decimal is 0.3, so all I need to do again is the percentage times the total, and I will get my answer. So 0.3 times 2,500 will be $750, just like that. For 22 and 23, they don't give you percentage, they give you numbers. So the first thing you should do is add them all up and see how many we have. When you add all these up, there were 104 total donors, 104 in all. To find how many were type O, again, it's just the number of type O, which is 38, divided by the total, 104, and you should get an answer of 0.358, 35.8%. For 23, this year's blood drive is expecting 65 people. So based on that, how many are you expecting to be type A? Well, this is just like the one we did on the last slide. What we do is find the percent first originally. Type A, there were 28 out of 104 total. But then we're going to take that number and we're going to multiply it by what my new number is, which would be 65. So I do 28 divided by 104 and then multiply by 65. And I should get an answer of about 17 people after you round. I think it was 17.1 when you do the calculations. All right. Next one, the stem and leaf plot. What score occurred most frequently? Well, here's where I'm seeing I have a bunch of these 3s in a row. The way I read that again is 73. Stem, 7, leaf, 3. Okay? You might see a million 2s all over the place here, but it's only about ones that are in the same line that matter. Median score, I'm going to cross off from the end. I'll do that in a second. Let me first do the range. The range is 123 minus 41, which is equal to, should be what, 82? I think. Or did I skip that one? Apparently I skipped that one. Okay, let's find the median score. I'm just going to cross off from the edges. So lowest and highest every time. Lowest, highest, lowest, highest, lowest, highest. Highest, and then from the edges here, low, high, low, high, low, high, low, high. I got two guys left here in the middle. So again, what number is right between 73 and 74? That'd be 73 and a half. Okay, so that's number 25. Number 26, to find the range there, yes, you're going to get 82 as your answer. So your answer sheet actually has those two numbers flip-flopped. All right, and on the last one, just looking at a line graph, this one, there's really no math to be done, to be honest. It's finding some pretty straightforward answers. In which month were the days on the market closest between a house and a condo? So where do you see the two numbers between the two of them the closest? Well, that's going to happen, looks like, right here in December. So in December of 2006. And they could even ask you, okay, how close were they? So that's what, 102 minus 82, that they were only 20 number of days away. Which month had the fewest days for a house to be on the market? So here's the houses. Where is it the lowest? That's happening right here at the beginning. It's in July of 06 when there was only 57 on the market. That's pretty straightforward just to read and kind of analyze in between them. A lot of this has no math to do with it. It's just analyzing work. So there you go. There you have it. Best of luck and take care of business.